Okay, so this is the second video that we're going to do, and what I've done is I've put 10 questions up, and we're going to factor them all. I'm going to do them in the order that I had the flow chart. I'm going to try and common factor, and then I'm going to count the number of terms, and so on and so forth. Today, we are not going to common factor and then factor again. That is a lesson that I'm going to do for Friday. It's very similar. You've already done it. It's just another step. So the first thing I would do is I would look to see if any of these questions is a common factoring question. So obviously 2 and 7, no way. No, there's an x squared there, but there's no x there. No. Again, if you want to write these down and try and do them first, then you're welcome to do that. No common factor here. 6, 11, no x on the last one. No. M and N. 2, 9, 7, definitely not. This one, no, this hasn't got any numbers, and this doesn't have any letters, so there's nothing common there. No numbers, no letters. No letter, and there's nothing common. Oh, look at this. Down in our very bottom here, we have the one common factoring question that I decided to do. It is really the first one we did. So the common factor for this one would be A, because you can divide A out of all of them. You can't divide out any numbers though. So our question, we're gonna take that out. And there we go. So that was a common factoring question, all right? None of the rest of them were, but you always check. Okay, so step 2, if we looked at it, was to count the number of terms. My dog is helping out again. So, my personal favorite is when I see 2 terms, I like the difference of squares. To me, it's a really quick, easy way of factoring. So if you look, oh, ding, 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 this one here. 2 terms. Is it a perfect square and a perfect square with a negative? Yes, it is. So this one is our difference of squares, okay? So this is where you put M at the front, and then you're gonna put 7N at the back, and then a plus and a minus, or you put a minus and then a plus. It doesn't matter, as long as you make sure those signs are opposite, okay? And if you wanna check it, multiply through, and you'll get what you started with. Okay, so we've done our common factoring. We counted and we see one with 2 terms. Are there any others with 2 terms? No. Okay, what about 4 terms? That was the other one that's very distinct, okay? And we've got one here. So I'm gonna think that this is probably a factoring by grouping question, okay? I'll drag this over. So I'm gonna look and see if I can take out, what can I take out that's common to the first 2 terms? Well, it's an x squared. And I think that's it. Okay, so what's that gonna leave us with? Y squared plus 7. And then what comes out of these 2? It's gonna be 2 y squared plus 7, yay! So this is our common factor. It's gonna come to the front, and x squared plus 2. And again, we're not doing any questions where there's another step after this. We're sticking with 1-step questions today. All right, so we've done common factor. We've done 2 terms. We've done 4 terms. These are all 3 terms. So the first thing you're gonna wanna do is look for ones that haven't got a number in front of the x squared. So this is a good one. This one actually it's just been rearranged a little bit, and so again we're going to talk about the fact that sometimes they can be a simple trinomial and also be a perfect square, okay? That one, I'm not happy with that one because I don't like the 2, I don't like the 6 on this one. I'm going to stay with this one next, and then this one, because those are both. Oh, and I guess I'll go to, and I'll probably do this one third. These are actually all simple trinomials, okay? That means that the value is 1 in front of the x squared. So then you just think of this. Okay, so let's go down here. What two numbers multiply to 20 and add to -9, -5, -4? Okay, that's it. Done. Love those. Up here, what two numbers multiply to 64 and add to -16? Well, it's -8 and -8. So this, not only is it a simple trinomial, it is also a perfect square. So I'll put simple trinomial and perfect square. It's both, okay? And this one's very similar in that. If it gives it to you this order, you can factor it in this order. You could also, if you wanted to, you could change it around and write it like that. It doesn't matter. Either way, we need two numbers that multiply to 121 and add to 22. And again, that's going to be 11 and 11. So, same thing. It's a simple trinomial and a perfect square. Okay. So I'm seriously going from easiest to hardest in this case. All right, so now we have 4 of these left. None of them have a 1 in the front. So the last thing we're going to do is, because we don't want to do a complex if we don't have to, are any of these 4 left perfect squares? And if we go down here, hopefully you'll see 16 and 9 are both perfect squares. And so probably 4r plus 3, 4r plus 3, or, as the back of the book is always going to write, 4r plus 3 with a big square at the front, or the back, sorry. So, sometimes if they were being tricky, or if it's actually a real life problem, this might not actually work out to be 24, in which case it would not be factorable, okay? Now, one of these in here, I believe I did make non-factorable, so hopefully I can remember which one that is. All right, let's see. I mean, these last 3 are pretty much all gonna be complex, and we are just gonna have to work with what we've got. So if we go up here, we need 2 numbers that multiply to -14 and add to -23. All right, I'm trying to go over this one, and what have we got? I don't know if this is, I think this might be the one that's not factorable, to tell you the truth. Okay, can you think of any? So what we're gonna, I'll try and use a different color again. Sorry, Mabes. All right, so 7 and 2 multiply to 14, and 14 and 1. Can you make 7 and 2 or into 23? Nope. Can you make 14 and 1 into 23? So I am pretty sure this one is not factorable. Okay, and I can show you how to check these all on Desmos in just a sec. All right, wow, so this one's gonna be massive. What is 6 times 35? Again, I do not have a calculator on me, so I am going to be doing the long division here. So it's 210. So, can you think of something that multiplies to 210 and adds to 11? And one has to be a positive, and one has to be a negative, because we've got this negative sign at the end. So I'm thinking 21 and 10. Yeah. All right. So let's do decomposition here. So 6x squared minus 21x plus 10x minus 35. Take the x out. Oh, we take a 3x out. There we go. Left with 2x minus 7. And if we take a 5 out of here, we're left with 2x minus 7. All right. Again, I did this by decomposition, but you could have done it by the cross product method. This one is probably what I'm going to do as a result. So let's try and do this the other way. So 14 and 9. So it has to, 2 times 7 is 14. So it's to multiply 14 and add to 9. And I'm pretty sure that's going to be -7 and -2. All right, so if I do this by the cross product method, I'm going to have, this is going to stay -7 over 2, so 2 and -7, and that's going to reduce to 1 over 1. So we're going to end up with 2a minus 7 and a minus 1. 2a squared minus the 2 minus the 7. There you go. Okay. So that's pretty much covered it all, going in the exact order that I would probably do them in, okay? Start with the ones that are the easiest to recognize and the easiest to do first, and then slowly work your way down, and if you have to, it's a complex trinomial, okay? Next lesson, we're gonna do a common factor, and then we're gonna take it out again. Now, one quick lesson, a quick note, and I will, do I have anything that, oh, these are all, I'm reusing paper. If you go to Desmos, okay? So if I was to go to Desmos and plug in this into Desmos, I would find that it does not cross the x-axis at a nice spot. That means if they're not nice numbers, or it may be that they're not even numbers at all, it may even be up like this, that means it's not factorable, okay? Okay, so if you have to and you want to use Desmos to check, that's one way you can do it. All right, an assignment is coming that you're gonna give your best shot at that'll be due next week. All right, thanks.